Right, welcome to this Dapr community call in October. My name is Mark Fussell. I'm a docs maintainer. We have a wonderfully packed agenda today of topics. We're going to start off with just me saying, actually, more than anything, the Dapr 1.12 release came out last week. We're thrilled by it. Please go and check it out on the Dapr blog. You'll see it packed with lots and lots of features inside there. And as always, we love people to try out the 1.12 release and give us some feedback. Beyond that, we're going to have Mohammed come along and talk about a case study from Vonage. We'll have Jonas to talk about combining Dapr and Tilt for great developer experience. Artur is going to dive in and talk about Dapr with LocalStack. Then Yaron Schneider will dive in and talk about the upcoming ST election. Marc always does a great effort of pulling together a whole bunch of work that's happened and activity inside the community. So we'll run through the community activity and then we'll finish up having some open discussion. Although I suspect that today, we're going to get a lot of agenda items. We won't have too much time for that. So with that, I'm going to hand it over to you, Mohammed, to take it away and talk about Vonage.
Sure. Thank you, Mark. Do you hear me all right?
We can, yes.
Perfect. So I'm going to share my screen. I'll make sure that you see my screen right now.
We do, yes.
Okay, perfect. So thank you, Mike and Yaron, for inviting me over. Mark, I'm sorry, for inviting me over. And thank you, Dagred, as well. Mohammed Attia, I'm a solutions architect at Vonage, part of Ericsson now. And today I'm going to talk about Dapr. So Vonage is basically a cloud SaaS company. So we build communication and unified communication APIs and contact centers and APIs around the network now with Ericsson. So we believe in Dapr, and we've been using Dapr in our core platforms applications, like core platform applications like the development portal. But we, in the architecture team, we've been looking into ways to increase the adoption because we believe that it's a great solution and it would add actually great value to all of the developers and engineering teams, making their life easier basically. So we looked around for popular use cases in the company, and as a company that provides APIs, then service communication or service-to-service invocation in Dapr terms is one of the great use cases that we could start with. So Dapr covers that pretty much well when it comes to, I would say, a service token to a service within the same cluster. We had a bit of a problem to cover a broader use case where your applications are deployed cross clusters, potentially cross over the globe, like in different regions and different continents. So we wanted to achieve cross-cluster communication with Dapr. So an application A deployed on cluster A in wherever in the world could call application B deployed in cluster B. They deployed in a separate cluster, separate region, separate environment. So the first thing that we had to figure out is how to get these clusters, two clusters communicate with each other. And we love open source. So for those of you who haven't tried Scupper, it's a great solution to secure or to do cross-cluster communication without a need of a Kubernetes, of course, for a VPN. And you can have a secure tunnel and we can have this traffic encrypted as well. It could be HTTP, could be HTTPS, or could be pure TCP/IP tunnel. And I'm not gonna dive into Scupper because we build internally a complete solution around it. So as an application owner, if you want to expose your application for other users to consume it, you can easily, in your deployment manifest, just write a couple of lines, like a CRD, and then we have our cloud operator that would work on initiating Scupper in that namespace and connecting the services together. So if we have a Scupper deployed, that makes sure that the two clusters can talk to each other. But now, how would we invoke the service, and how would we make that go through Dapr? So we had some challenges when it comes to that. The first challenge that we were thinking of is basically, since these are two different Dapr instances deployed in two different clusters, then we wanted to configure them to have the same certificate controller, and in our case, it's cert manager. And I believe that this became available in Dapr 1.11. Yaron, correct me if I'm wrong, where you can configure Dapr to use external certificate controller like Dapr Sentry service. And also we wanted to do, like in this use case, we wanted to make sure that application, because Dapr does well when it comes to new applications, but for existing applications, in order for them to call like a Dapr service, they have to tweak a little bit their the request to the service, like including the header or rewriting the URL. But we want that to be transparent to the application developers, so we don't want any code change. And that was like one of the challenges that would like run into. And the most important one, which is more of a breaker here, is the way Scupper works. So if you want to expose, let's say that you have your Scupper tunnel or Scupper connection initiated between two namespaces in two different clusters. So these two namespaces now are connected kind of together. But now you want to expose some workload or some application to be seen on the other side. And the way Scupper works with annotation. So we're thinking that we can annotate the Dapr service with the Scupper annotation, so it could be it could show up actually in the other cluster. But the problem is Dapr generated service is immutable. So once you annotate it, it reverts back like this by the Dapr operators. So it doesn't let you, like Dapr doesn't let you actually control their service, the dash Dapr service, that's the one I'm talking about. So, well, we've been faced with these challenges, and now we had to think of a solution, because now we have to go outside of Dapr to do this routing, or not to rely on Dapr for service-to-service communication. And what we've noticed in the 1.11 version of Dapr, that you can call a non-Dapr HTTP endpoint from a Dapr sidecar. See, we actually wanted through this route, and we changed a little bit our design to include an Nginx sidecar that would act as both forward and reverse proxy deployed in front of your application. And the reason we did that is because basically it will let us control the MTLS now, since we couldn't get like the Scupper to work with Dapr. Then we shifted away from Dapr, like from the MTLS part, but we still wanted all of the other features that Dapr does when it comes to service communication, like the retries, the metrics, and all of that. So basically, we came up with this design here where you would have your application calling the Nginx sidecar as a forward proxy, and then the Nginx will rewrite the URL, so the application doesn't have to worry about changing their existing code that calls the service that is deployed on a different cluster. You just need to provide the URL. You don't have to need to provide anything in the request header. They don't have to do any URL rewriting or whatnot. Nginx would do that transparently. And then Dapr will actually forward the call to a non-Dapr URL. And from here, we're a little bit stuck because Dapr did not support calling a non-Dapr URL till version 1.11. And we were very pleased about having this feature 1.12, where you can call a non-Dapr URL, an HTTP endpoint, and configure it with TLS as well. Do you hear me all right? Because I can hear some noise in the background. So do you hear me all right?
No, we can hear you well. Everything's perfect.
All right, perfect. So as you can see here through this architecture, I have a cluster where the pod is deployed here, and this pod have like two sidecars. One is the Dapr and one is the Nginx, and it's deployed in its own namespace. And then what a Scupper will do is will create, if you configure it correctly, basically, if you do the Scupper tunnel here, if you annotate the service of the application P by the right annotation, and then you connect to it from the namespace in the second cluster or another cluster, it will create a shadow service that has the same service port, but the target port will be different. So the target port will go to the Scupper router, which is basically route the traffic to the other cluster through the Scupper tunnel, and it goes to that service. So in your cluster, your first cluster, you will find yourself ending up with a namespace that is the same namespace as if your application B is deployed in your cluster A. It doesn't have the pod, it's just a service. The same exact service, but the target ports are different. And then when this call, like, so all of the calls inside the pod, they're like non-secure for the moment. Like we have this, the application is calling HTTP call to the Nginx, and then Nginx is calling Dapr, like rewriting the URL. There's a little bit of enhancement that we're thinking to do here, which is utilizing the token feature. So like Nginx can authenticate to Dapr. And then Dapr will call a non-Dapr URL, which is secured, TLS secured. And then the call will be routed through Scapper to the second cluster. And then it terminates at the Nginx proxy that does the decryption, because these two Nginx servers, that's another part that is not actually here in the architecture. So these two, like written in this diagram, these two Nginx servers are configured to read the certificates from Cert Manager. And then there is like a third part, which is more of a cloud operator that will make sure that the root certificates are replicated across the clusters and namespaces. So the encryption happens at the Nginx, it's passed through Dapr, and then it comes at the engine, like the Nginx reverse proxy on the second application, and then it gets decrypted, and then it goes to Dapr to invoke any pipeline or anything that has to do with an incoming call, and then it goes to the application. It has lots of technologies and lots of open source technology, but this is actually working perfectly fine. And well, that's actually the call scenario that I was explaining. So the application A will call application B service through the Nginx forward proxy, and application A sees the application B service because this service has been created by Scupper. And as you can see here from the application perspective, it's just calling another service that, as if like this service is a local service. So it'd be like something like an app B service in an app B namespace.service.cluster.local. And this service, of course, is listening on port 443. And this is like a hello endpoint. So applications making an HTTP call, but then it gets terminated at Nginx, and Nginx encrypt the call with the proper certificates coming from Cert Manager. And that's exactly what Nginx is doing. So it does the MTLS part and then forward the call to Dapr using the rewrite property in Nginx, and it will call a Dapr HTTPS endpoint that is app B endpoint, which is configured to use the same certificates. And then the call is routed through the Scupper, and then the call gets encrypted at the reverse proxy and forwarded to Dapr again as an upstream server. So what I like about this is basically we've been trying to do this, I would say, since Dapr 1.10, but we started with fixing the problem around cross-cluster communication and building a solution around it first, and then we came to Dapr. And then we've seen features of Dapr evolving. So right now we're using this one, which is 1.12 feature of creating this endpoint, which I would love if we can have this kind of how provided without the need to recreate, or I'm sorry, to create an extra HTTP or an extra Dapr resource. So make our life a little bit easier. So basically, this is part of the deployment manifest. If we were using, we're not actually letting our engineers and developers use plain Kubernetes manifest, because they will have to write like 269 lines of Kubernetes deployment files. We use OAM, Open Application Modeling. So this 270 lines roughly, you could end up doing it with our OAM application traits and all of the stuff, customization that we've done around it. You'll end up doing like it within 23, with like 23 lines. And this Dapr trait here will take care of configuring Dapr, creating the Nginx, managing everything that is related to the certificates. And of course, we're taking this as an input so we can create also the HTTP endpoint. Unfortunately, I cannot do any demo at the moment because I was not quite sure whether I can do that. Kind of proprietary, we cannot share. but I make sure that next time I ask the right people so I can get permission and show you guys how does it work, like in a real live demo. And that's it, Mark. Back to you.
This is pretty cool. So in the end, you found that, you know, this cross-cluster communication had good latency and you're able to achieve your objectives, yes?
Yeah. It works pretty cool. I was just looking for adoption, like people to use it.
Well, is there any questions that people want to post and ask Mohammed about this? One question is, does Skipper require a port to be exported? Skipper.
Well, you can go to scupper.io. We can have a separate session on Scupper, actually.
Yeah, we can do a separate session on that.
But I appreciate if the community would let us manipulate, like not fully. I understand that this is by design for security purposes, but we couldn't. If we could like annotate the Dapr service, it would have made our life easier and get rid of the Nginx sidecar. The second thing is, I know that the HTTP endpoint is a great thing, like you can configure it with TLS and stuff, but if we kind of can do that without adding an extra resource, it will be also great.
Okay.
Like some headers or some environment variables. I don't know, not sure. Like the way you do the installation of the certificate.
Well, this is fantastic. Thanks for sharing. If there are any more questions, post them in the window and Mohammed can answer them there. And maybe you can come back in a few months' time, if possible, and even show us a demo. So we kind of maybe look towards getting you on a future community call if that looks good.
Yeah, next time with nets.
Sounds good. All right, with that then, I'm going to move on. And Jonas, take it away.
Thank you, Mark. Let me share my screen. Is that looking okay?
Yes.
Go to slideshow. Yeah, hi everybody. My name is Jonas Juselius, and I'm the CTO of a startup called Oceanbox. Oceanbox does high-resolution advanced oceanography as a service, essentially. I'm not going to talk about much what we are doing, but rather than what we are using. We're very happy Dapr users. I have been for slightly over a year and like it a lot. But this is something this has very little to do with Dapr actually, but it plays really nicely with Dapr. So the problem I'm going to talk about today is basically how to maintain a good developer experience developing cloud applications, because it can become quickly very, very painful. I'm sure there's more than two options, but the two common options is that you are developing some kind of microservice. You have some components, and you have an interface, user interface, and you try to program this, and you end up replicating this locally, setting it up either using Docker Compose or combinations of Dapr Run or K3S or whatever. Which is the good thing is, of course, that it runs locally, but the bad thing is that it really gets quite complicated, and in my experience, you end up duplicating a lot of configs and making hacks and horrors to make it work. And in the end, it becomes very, very brittle. And you need to sort of maintain two sets of configurations. Another bad thing is, of course, resource consumption, because if you're running 20, 30 different services, and some of them might be quite resource hungry. Like on Oceanbox, our typical data models that we are using and serving are of the order of 50 terabytes, and they don't really fit on my laptop. So that's also a sort of a practical problem. So the other option we have is to deploy it to the cloud. And that's, of course, really nice, because we probably already have existing pipelines and all the manifests and everything, so we can just send it to the cloud. But the bad thing is, of course, that it goes insanely slowly to update things, particularly if you're going to sit and wait for CI pipelines. It's like you add a print and you wait for 20 minutes until you can check. So debugging and developing becomes very, very slow. So this is where Tilt comes in. And Tilt is a wonderful little thing that takes care of 2.5 problems. it monitors your local resources and manifests. It does whatever it needs to sort of keep those resources up to date, and then it synchronizes those to live to Kubernetes. And the point 5 here is setting up port forwarding for you automatically, so you don't really you get really a transparent local environment. And the good thing about this is that it allows you to reuse all your existing manifests. So if you have a production manifest and you have staging and review manifests, you can just reuse all of those. And the nice thing is that everything will be running in Kubernetes in the sort of real deployment environment where it would run in production. So there's no tweaking and twiddling to get things to run. And it turns out that it's quite easy to mix and match services from different environments using Tilt, so that you can use part of the stuff that you're working on might be services running in Tilt, and then you can add things running in production or from staging environments. So you can pull in all these different environments in your Kubernetes cluster and just mix and match services to some extent, at least. And what Tilt sort of does is just, it focuses on reconciling resources. So whenever you change a source file, Tilt will monitor it if you ask it to, and then it will rebuild your code. If you change a manifest, it will rebuild that. Then it will build containers for you, and it will push all those changes to Kubernetes. And it can actually do something quite nice, because one way of operating is that it builds a container, pushes it up to the registry, and restarts the container on Kubernetes. But it can also hot swap directly inside pods, which is sort of a kubectl copy, changed files into this thing and restarting it. So it's kind of nice. Tilt itself is typically configured with a short little script, which is written in a language called startlark, which is pretty much Python. Some kind of sandboxed Python. So anybody who knows Python knows how to program Tilt scripts. So with Dapr and Tilt, so it's really nice because it allows you to build and develop your Dapr apps locally. You don't have to do Dapr run to sort of connect your app to the other Dapr apps running in Kubernetes. Everything will be running in the cluster. Tilt will streamline all the logs straight into your web browser, so it's really easy to see what's going on. And whenever you change something, Tilt will pick up the change, build, and synchronize the change in a few seconds. And so typically you change something, you wait 10 seconds, and the new version is running already in Kubernetes, and you can test it. But there are a few challenges that one needs to take a little bit to look into. One is hot module reloading, because if you're doing JavaScript or some kind of browser-based thing, you're changing CSS files and you're making small changes. And hot module replacement is really a nice feature because it allows you to see the changes instantly. And of course, the way Tilt operates is that it's pushing all these changes to a pod in Kubernetes, and if you do that, then you lose hot module replacement. But there's a workaround which works quite nicely. And the other sort of little pain point is if you are like me, very keen on using actors, there are some issues with that. I'll talk about that briefly. So by default, Tilt will just build and update containers and pods. But we can actually get back hot module replacement by doing a few tricks. So what we need to do is simply exclude the JavaScript code from the standard updates so that it doesn't get updated whenever you change a client-side file. And then what we will do is that we will locally on our machine land something called a local resource, which will run a Vite or Webpack dev mode server, which has a web proxy on it. And then ask Tilt to put up port forwarding so that the instead of the normal Webpack or Vite server talking to the local server, it will use a Kubernetes port forward to talk to the updated service which is running in Kubernetes. And then just connect to localhost. We develop like normal. Every time we change something on the client side, it will get instant updates. And if we change something on the server will be updated immediately. The only little sort of nasty bit there is if you are doing single sign-on things and have SSO cookie domains and blah blah and HTTPS and stuff, you need to configure some certificates and do a little bit of DNS mask tweaks to get the domain names right for the cookies to flow. But that's sort of the usual monkey business of doing those things. So that's hot module replacement. So I like actors a lot, but there's an issue I think with, and the Dapr folk can probably elaborate on this, but currently at least actors are not namespaced, and this is a little bit of a you figure this out pretty quickly when you have various CI environments running on the same cluster. So if you have production, staging, and review apps on your cluster, and they are using actors, you push up a new staging version, and it will badly break your production system, because there can only be one implementation of an actor active inside the same Dapr instance, and this is sort of nasty, because if you don't know this, you're up for a surprise. The way we solved this was simply to use V clusters. And for those who aren't familiar with V clusters, they are super lightweight full-fledged Kubernetes clusters that you can run inside of a namespace. So they're really easy to set up. Once you do, it will fire up a K0s or K3s service in that particular namespace. And then inside that namespace, you can access this cluster. And within that cluster, everything runs in a sandboxed environment. So this allows us to, again, put up a private, isolated Dapr instance inside of this V cluster, and then deploy our Tilt services to the V cluster instead. And everything is nicely isolated from each other, and actors work like they're supposed to. There are some nifty things with the V cluster, which allows you to share resources between the hosting cluster and the virtual cluster. So which makes it really easy to sort of, you can have one RabbitMQ instance and you can have one Kafka instance and the databases and everything, and you can just sort of share them into your V cluster, so that you have your base service inside of the V cluster. Another positive thing with the really good thing with the V cluster is that tearing down environments is really easy, because you just delete the V cluster and everything is just poof gone. There's no cleaning up to do than just deleting the V cluster. So I have I'm not going to show very much about how the Dapr files look, the Tilt files look, and how everything is set up. I have put up a repository on my GitHub. You see the link here, and there is a demo, fully self-contained demo project with a silly little client-server app written in F#. And there's some Helm charts with some customizations. I actually added a full V cluster setup with some scripts to set up the V cluster, and there's some Tilt files and some Vite configurations for how to do the hot module reload. So I'm just going to do a quick demo of how this actually works in practice. So here's the project. Pretty much sort of standard thing. There's a folder in this project called V cluster. I'm just going to do a create vCluster and call it demo. And this will now fire up a vCluster for me. This takes about 30 seconds to have a new Kubernetes cluster running inside of the Kubernetes cluster. This script here is just for convenience. It also sets up some secrets, and it sets up Dapr for me automatically. Everything is ready and configured, and some role bindings so that everything is ready to use. So there we go. Now it's installing the Dapr control plane, and it will be finished in just a second. There we go. Okay. So now I can connect to my vCluster using vCluster connect demo. And let me just do K9S. And we can see that here it is. This is showing all the namespaces on the vCluster, and the Dapr system is up and running. So that's all good. So just to show you how the tilt file looks before I fire it up, this is how it looks. And I won't go through the details here. I do a little bit. This is actually very close to something that we use in our daily work. So it should be pretty easy to adapt to any use case. The big thing here is that you define some manifests, define some Docker builds. This is Docker build with restart to sort of, you need a special little extra extension for Dapr for it to be able to actually restart the service inside of the container without killing the container. But that's it. Okay, so let's see how it works. So now I'm going to run tilt up. And I can press space, and that will open my web browser, and we get this little tilt dashboard that we can look at. And we'll see here that it's going through some stages. Now it's running the create bundle. That was done. It's building the server. We can look at the build logs. We can look at the application here, and it's pushing up the container to the. So that was done. Now we should soon see the logs that the application is running. There we go. There we see the Dapr logs, and here now the service has started. So this service here, I made it use the pub sub thing, so it's actually listening on a pub sub RabbitMQ running in. So where the RabbitMQ is actually in the containing cluster. Okay, so now everything is up and running. There's a client running. I can see that it's running on localhost port, so I can click. Wow. Okay. What? Oh, sorry, wrong port. There we go. So here's the app. So this is the app now that I have written, silly little to-do app. Can interact with it through bar, and of course we want to just to show the hot module reloading. So here's the to-do, which is in the title, so I can just change that to foobar. We go back to the browser, and it says foobar. And this is now running so that the client is served from my local machine, and all the traffic is going into our Kubernetes cluster where the server is running. And I can change something in the server as well, and we can see how Tilt will respond to that. So we can go and do something here. Create no new project, and we can go back to, and we should see where's my Tilt. Did I zap my Tilt? Yeah, I did. Yeah, so start it again. It's already updated, so I didn't. But we should see here that it says, "Oh, now listening on." It has restarted the pod. So that's basically Tilt and Dapr, and I can highly recommend Tilt because it really makes life so much easier.
Pretty cool. So you've found that you've been able to speed up your development time and your productivity by using Tilt, yes?
Yeah, enormously. I tried. There are some sort of experimental solutions for tunneling Dapr and tunneling this and that and tunneling things, but there was a lot of friction, I think, with a lot of the other things that I tried. But Tilt is just wonderful, and it's built on some quite general and simple principles, so it works fantastically.
All right. Well, thank you for sharing that. Would anyone like to ask any questions, either in the chat window or open up their mic about, using Tilt?
Yeah, I have a question for you, Marc. As the documentarian that you are, how come you've not asked Jonas yet to write docs about how to integrate Dapr and Tilt?
Yes, actually, yeah. In fact, just the other day, we had a contributor kind of give us some great documentation about using Docker Compose and how you put all that together. But yes, would you be able to put something together? We're going to include this video, of course, which is a great way of doing it. But if there's a little doc that you would submit just to kind of combine the two, we'd love to include those things as part of our development tools in our section inside the docs.
Yeah. So there's this. Of course, you can have a look. You can have a look at the demo project, and I really urge you to try it out and use and look at that. I can try to at some point. I can try to do some simple little how to do a really minimalistic Tilt thing without all the hot module reloads and resource sharing and V clusters and just the sort of really basics of it.
Yeah, that'll be highly appreciated.
And could you share your link in the chat window for your project so people can go to that, and what does that, then it gives a full example of using Tilt, yes?
Whoops. Hit the, there we go. There we go. See. Yes, I'll just post the link here now. Yes.
All right, any more questions before we move on? Okay, thank you for sharing. That's fantastic. Look forward to
thank you.
Down. All right, next up we have Artur. Artur, would you like to share your screen?
Yes. Yeah, let me see if you can share my screen. Yep. Okay, so let me open the SlideShare here. Can you see the slideshow?
Yep.
Hello?
Yes.
Go.
Yeah.
Awesome. So this is a quick demo. It's not going to be as extensive, but I'm going to show also an interesting tool that we have used for our testing, and that you can use locally as well. So for those who are not familiar, LocalStack is basically a local emulator for AWS services. So this way you can actually use AWS services without even using their cloud or their console being charged. And it came very handy when we were doing certification and conformance tests for AWS components. So if you want to try that out locally, so you basically install the CLI, the LocalStack CLI with Homebrew. There are other options as well. You can go to their website and check it out. You can also install, you also need to install the AWS CLI and the AWS CLI local. AWS CLI local is like a wrapper on top of AWS CLI that would talk directly to the LocalStack localhost endpoint. And to run, you just do a LocalStack start. And how we use it. So we use it at conformance tests for AWS components. You can see how there's an image. You run that as a container, so you can use Docker Compose as well. And there's a localhost port that you listen to, and there's some volumes here for to bootstrap the resources. But Dapr can also provision those for you automatically in the component. So it's actually very easy to use that for PubSub, for example, which was going to go demo today. How do you configure a component in Dapr with LocalStack? So it's the usual AWS components. You still have to provide an access key and secret key, even though you don't need it for LocalStack. You just put some value, put X, just because a random value. The region, the default US East 1, I kept that. And you have to provide an endpoint, which is the localhost endpoint. So this is the bare minimum you need to use LocalStack with any AWS component. And I will show a demo. So I have now recorded this. So let's see. LocalStack, start. Okay, there you go. It's running. Now let me open my, after running that, I'm going to go to a new terminal. Now we know that's running. And we are going to get into one of the tutorials. So if you're familiar with the Dapr tutorials, I'm going to use the PubSub tutorials to show how that will work. So just to confirm, the component is the same way you saw in the slideshow, right? It's a PubSub component. And after that, we're gonna now go into the Python subscriber, and let's run that the same way we are using before. So there's no change at all in the quick start. The only change is you have to make sure the components are actually using AWS. So we got that. Now I'm gonna go to another terminal, and we're gonna see the publisher UI. 1 minute. So the usual way you run the tutorial, there's no change. And now we're gonna open a website here, and then demo at the community call. And then I'm gonna submit that. And then, of course, you're going to see that in the publisher and also the subscriber. So you can see like how the component works seamlessly with LocalStack just via the configuration. And then you can also see how things got added for you so you use AWS Local, which is a wrapper on top of AWS CLI. And in this case, we're going to list the topics. And the way this particular component works is that SNS is for the publisher side. So the publisher will publish to these topics, A and C, just because these are the two ones used in for the Python subscriber. And then for subscriptions, you can see how the Python subscriber subscribes to topic A and subscribe to topic C. And you can also see how that gets delivered to a particular queue. So the C topic will land on SQS. That's how this component works. And if we list the queues, you can see the Python subscriber queue there, which is how the application receives the event. So that was a quick demo. There is more you can do with LocalStack and Dapr, but if you're working with AWS, it's kind of a must to use this tool for your local development. So yeah, that's it. I'm going to stop sharing. Any questions?
That's pretty cool. Does it support all the AWS components? I mean, does it, or is this a subset?
For my, let me look at the documentation file. I think I wouldn't say all, because sometimes it's always like an exception, but I see most there for LocalStack. It's a pretty used component service for people that use AWS. So yeah, I would say most at least.
So you can save quite a bit of cloud costs because you can run everything locally.
Yes, you can run everything locally for AWS. But of course, it's not reliable. You cannot rely on the data, right? So it's basically for testing local development.
Yeah.
I guess I can chime in here. So because like I'm working at LocalStack, so we basically emulate over 90 AWS services in total. I guess the number is almost 93 or 92. I'm not sure about that, but yeah. Coming to the reliability part, I guess we have a coverage page. I guess I can just link it over here so you can actually have a pretty granular look on what APIs are working out with what sort of compatibility with the real AWS cloud. So that would certainly give you a lot of confidence in what you're exactly building. I hope that should surely help. And thanks for the awesome demo. I would love to try out Dapr with LocalStack someday.
Yeah, that's amazing, Harsh. Thank you for joining the call and giving us the insights around those things. Perhaps we should find some time to dive in even deeper, Artur, and bring some other examples together in a future one. Can we just use this as a taster and dive into more in the future?
Okay, thank you.
Okay, thank you. Right, with that, then we were going to move on, because we have the last 10 minutes. And thank you for showing that demo, Artur and Yaron.
Yeah, I'll share my screen and cover this real quick. Let me know when you can see it.
We can see.
Yep.
Yeah, all right. Cool. So today I am talking to you as a Dapr steering committee member, and we have a few of those on the call. Hey, Paul. Hey, Mark. And I'm going to cover the 23 election that's now coming up. So every 2 years, Dapr has an elections process to call for nominations from companies who are adopting Dapr or contributing to Dapr. So this is what we're kicking off this year, and I'm going to cover the timelines real quick. So the first milestone that we had was to issue a call for nominations. That's for people who want to become candidates for running for the Dapr STC. And by the way, if you want to learn more, we tweeted about it yesterday, I think, and there's also a Discord message. And if you visit the Dapr blog, you have all the information there. So there is a call for nominations that was announced on October 16th. This call for nomination closes. So if you want to run for Dapr STC, you need to get your candidacy in via PR to the community repository by November 6th, which is 3 days before my birthday, if you're wondering and want to send me a gift. And then by November 7th, we publish a list of voters and issue a call for exception. So as a voter, not as a candidate, you need to know if you're able to vote. And so there will be a list that lists all of the GitHub IDs of all people who are eligible to vote for the Dapr election, and we will announce that. And there is also something that's called a call for exception. So what is an exception? Our rules, like many other CNCF projects, basically state that you need to have 20 contributions into the Dapr project to be able to vote. But the contribution isn't necessarily a code contribution. It can be a GitHub comment. It can be a conversation on Discord. It can be a public meeting, can be a community call show. And so if someone doesn't see their name or GitHub ID on the list, they can issue a call for exception and make the case that they should be allowed to vote. The voting itself starts November 13th. It ends November 27th. The results are announced November 30th. And then the new steering committee takes office on December 1st. And that's basically the process. Now, one of the most important aspects of this election is the role of the elections officer. And that's a highly important role to make sure that the elections are impartial, that everything happens according to our rules and to the CNCF rules. And we have announced an elections officer. His name is George Stevens. He's here on the call, and I will let him introduce himself. George, are you here, and can you unmute?
Okay, I'm unmuted now. Yeah, hello, I'm George Stevens, and I'm your election officer. And basically, you could just ask for help from me if you're having trouble trying to prepare your candidate statements or get signed up or figure out what's going on. That's one of my key roles, is to help people through the election process. So you can just message me on Discord, George Stevens 99, and I'll help you. That's all I have to say.
All right, and thank you again for taking this role. This is extremely important, and thank all of the Dapr community for your nominations that are going to come and for the voting that you're going to have once we open up voting. So that's it. I'm going to stop sharing.
Thank you. And thank you, George, for helping out on the voting process. Right, to close out, Marc will give us a rundown on the latest that's been happening in the last few weeks in the Dapr community. So, Marc.
Yes, hi everyone. Marc Duiker, one of the Dapr community managers. Apologies up front because I'm in a hotel in Porto with bad Wi-Fi. So I hope this is understandable. Let's quickly go through all of the blog posts. So quite some things have been written. The first one is a comparison, more like a performance comparison between like Azure Functions, Dapr on Azure Container Apps, like
Marc,
processing messages. Quite interesting.
Marc, I think you need to share your screen. All right. Or I can share the screen for you.
I think he's not on the call anymore.
I think he's not on the call anymore.
Oh, no, sorry, that would be bad.
I am still here.
Yeah.
Let me try sharing again. It says screen share is loading. Yeah, I'm getting messages that my internet connection is unstable.
Let me share and you talk me through it. Let me do this here. I will share.
I think it's coming up now.
Let me stop sharing. That's probably easier, indeed. Yeah. Okay, if you can share, Marc. Can you share?
I can, yes.
Yeah, let's do that.
There we go. Take it away.
All right. So, in this list, there's a couple of high-level overview ones of Dapr and a couple of specific ones. So, the first one is a specific one about performance. The bottom one is quite a nice one by Marc about workflows as code, and of course also Dapr workflow, which is a very nice one. Let's move on to the next slide, please. On YouTube, the last 2 weeks, this was indeed one of the new videos. It's one that I made about sync and async microservice communication with Dapr and JavaScript. I mean, there is a T there, but it was playing, so that's why you don't see it. Next slide, please. Of course, we already mentioned this. 1.12 is out, and there were a couple of nice reactions on this as well. So if you could show the first reaction, the next slide. So first reaction by Massimo, who was very happy with this new version, and says it's running thousands of devices connected to the application. So it's good to read these messages. Next one, please. Here's one by Jellyfish. I think they're also on this call actually now. They tested the Outbox feature and it just works. I just retweeted this with the comment that the Outbox feature just works out of the box. I'm very proud about that joke. So Artur mentioned earlier this week that it's Dapr's birthday, 4 years old now. So yeah, I think we have to send out some cake next year when we turn 5. I definitely recommend to read this blog post. This is the announcement blog post. Yeah, it's nice throwback. Right, next one. I was at Developers Days Eindhoven last week. I did not give a Dapr talk there, but I did pass around some Dapr stickers. Next one. So Christoph was at a Cloud Nord event speaking about Dapr. So it's quite a busy room, as you can see. It's great to see always. Next one. The state of Dapr report is now final and it can be downloaded. So please check this link, and there's a link in there to the actual report that you can download. Right, next one. I was at Techorama, it's a big developer conference in the Netherlands, and I brought a lot of Lego with me, and I was asking the attendees there to come and build some Lego microservices. I used Lego as an analogy for Dapr, so this led to quite some interesting conversations about Dapr and all the APIs. So Dapr is also mentioned in the InfoQ Software Architects newsletter, so that's good news. So Dapr and the Dapr workflow was also mentioned in Azure Day Torino recently, and also using some of my slides. I see it's also fun to see. Next one. I did a tech talk last week in the Netherlands about Dapr 101. It's a good turnout there, and I think this is the last update. It's about another meetup in Copenhagen on November 9th. Out modern clouds and the development also includes session about Dapr. All right, so yeah, I still need to copy all these links to Dapr Discord in the show and tell channel. If you find something yourself that you would like to share, or you find something by someone else, please post it there as well. Thanks.
All right, thank you, Mark. And I'm going to thank you, Mark. Well, and for joining everyone today. Wonderful update across all the speakers. I want to thank all the speakers once again, and we'll see you in 2 weeks' time. With that, I'm going to close out the call.
Thank you.
Thank you.